Okay, in this problem, they want us to sketch the graphs of these three equations, okay, on the same axes. So here's how you do it. The easiest way is just to use the calculator to generate the points. So let's try it. So here I'm going to put in y equals x, right there, squared, the squared, oops, I'm sorry, you can't see that. I put in x here, that's the x, and then the squared button is down here, x squared, and then we want plus 5, okay? And now I'm not going to look at the graph. I could, and it's going to show me that, but that's not going to give me the points I need, okay? I need the points that are on this graph. So I'm going to go up to the table here. So I'm going to hit second table, and it's going to show me the table values. And what I'm really looking for in the graph is, like, I want some points on this side of the symmetry, and I want some points on this side of the symmetry. So we need to know how to find that symmetry. Or we want to know, how to find, like, where does this thing turn? Where is it symmetric? So we go to the table, and here's the trick to finding the symmetry. Look at, the x is always going to count by ones, or whatever you have it counting by, -3, -2, -1, 0, etc. Over here, though, look at here. We have -3, 14, -2, 9, -1, 6, 0, 5. But now look what starts to happen. It went 14, 9, 6, 5, going down, but then now it's going to go back up, 6, 9, 14, in a perfectly symmetric way. So this is where that symmetry is, right here at 0, 5. That's how you tell. You find the symmetry over here, and that's how you're going to tell. So I found the symmetry here, so these 7 points are sort of good ones to plot. Or maybe just the middle 5. So I'm going to come down here, and I've got our graphs here. So I just literally take the points off of the table. I started with -2, 9. That's right here, -2, 9. Here's my x-axis and y-axis. -2, 9. -1, 6 is right here. 0, 5 is right here. And then 1, 6 and 2, 9 is up here. And then I connect those to make the graph of y is equal to x squared plus 5. For the next one, we had y is equal to x squared minus 4. Okay, so I put in x squared minus 4, and I go through the exact same process. I go to the table, I find the symmetry, which happens to be the same. We see the 5, 0, -3, -4, and then -3, 0, 5. There's the symmetry there. I plot these points. And it gives me this graph here. Boop, 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 boop. I sketch it through. And then the y is equal to x squared plus 1. I do the same thing, and it ended up looking like this. So what I'm noticing is the only thing that's changing in these three graphs, x squared plus 5, x squared plus 1, x squared minus 4, is that third term there, the plus 5 plus 1 minus 4. And if I notice, it's taking the basic x squared graph, and in this case it's shifting everything up 1, in this case it's shifting everything up 5, and in this case it's shifting everything down 4. So that's what that plus c does. In general, y equals x squared plus c, that plus c slides the base graph, which is y equals x squared, up or down c units.